Right, this is the major bit of excellence for rate of reaction, okay? And for excellence, you have to explain the speeding up or slowing down of the rate of reaction using terms about particles. So first up over here, what do we mean by particles? We're explaining things. We're talking about the particles, which could be atoms, ions, or molecules, or any particular reaction. Could be any combination of those three things could be reacting. Another note is that surface area is judged by the size of the pieces. For example, lumps are big, grains or small grains, fine grains are smaller. Really fine is powder, really fine grains, and we'd refer to those as grains or talk about grain size and not particles. So for the surface area, we refer to the size of the lumps. Right, if the concentration is concerned, you must explain what concentration is when you're talking about particles. What is it? It is the number of particles in a given volume. Sometimes a diagram helps. You show two beakers the same size and have the same amount of liquid. Those beakers, by the way, are the same size. It's just your eyes are not very good. They look different. So in a dilute solution, few particles in that same volume. And in a more concentrated solution, you have more particles in a given volume or set volume or the same volume. What happens when the factor increases? When concentration increases, the number of particles per litre goes up. Increases is usually the word we use. Goes up. Okay, just like here, goes from there to there. Number of particles in the volume goes up. As you can see, they're more crowded, more likely or probable to bump into each other, or they bump into each other more often. Okay, so why does that increase the rate? More particles in the same volume will collide, and that collisions and collide you can't explain without the word collisions or collide, or both in there. More particles in the same volume collide more often. You must use a word like often or frequently because that refers to the amount of time, and the rate is completely mixed up with the amount of time. Okay, collide more often, more frequently. Therefore, there will be more frequent successful collisions. Now, there is another word or approach this increases the rate. I refer here to the time factor with often and frequency, but you can refer to the probability of collisions and the probability of successful collisions, because those include a degree of how often collisions will occur, and that of course affects the rate. And don't forget to tie it back. This increases the rate of reaction. So making that, what is the factor? Define the factor, give its meaning. Concentration is the number of particles in a given volume. What happens when you increase the concentration? the number of particles in the given volume goes up. They become more crowded, so they collide more often. There will be more frequent successful collisions, which is what actually decides the rate, is the number of successful collisions per second, and that increases the rate. Okay, so do exactly the same with the temperature. We have to define temperature. I just need the space. So temperature, what is it when we talk about particles? And temperature has to do with energy. Temperature is the, and technically speaking, the average kinetic energy. You've got to mention the kinetic energy of the particles. It's instant you start to mention energy when you're talking about temperature and the particles, you are probably going to score an A mark straight away. So there's still A marks to be had in this explanation. Is the average kinetic energy of the particles involved? What happens when the temperature increases? When the temperature increases, the particles get more kinetic energy. They move faster. They collide more frequently. They react more frequently, that is successful collisions. That is successful collisions. And the rate increases. So that's simply because if they have more kinetic energy, they move faster, they collide more often, there'll be more frequently successful collisions or reacting collisions, therefore the rate increases. There's actually a second factor, because they actually hit harder, the collisions are more efficient at reacting because they hit harder, they have more, each collision has more kinetic energy and is more likely to react. So we could include that. Either one of those will get you the full mark, okay? Collisions also have more energy and reaction is more frequent. And the fatal thing is that kills a lot of these excellence marks is immediately say the number of collisions. You can get away with it as long as you say the number of collisions per second. That's frequency. The number of collisions per second, number of collisions per second. The minute you say just number of collisions increases, explanation dead in the water. The rate of reaction has to do with time. There must be a time factor in there of frequency or how often things happen or how many per second. But if you just say the number of collisions goes up or goes down, depending on what your explanation is, it's all over. Okay? So, temperature is the average kinetic energy of the particles. When the temperature increases, the particles get more kinetic energy. They move faster. They collide more frequently. They react more frequently. More successful collisions, that is, and the rate increases. You can also approach from the fact that each collision has far more energy and therefore more frequently they will react or be successful. And that increases the rate. Okay? Right, so that is temperature. And lastly, we come to surface area. what is it? Surface area is the number of particles. This is separate from the actual explanation about rates. Surface area is the number of particles exposed on the surface of a solid for collisions to occur. So there's another thing that you have to remember, that if you have, say, a kilogram and it's big lumps, it has a low surface area, but you have a kilogram of powder, it's got a fine surface area. You put the lumps into something and they bubble away. You put the powder into something and it'll just fizz very quickly because of the massive surface area. So making smaller grains gives a massive surface area, a bigger surface area. Okay. Larger surface area exposes more particles for collision. And I'm going to put some detail here with the particles of liquid. Collisions are more frequent. I'm just going to run them both together here. So collisions and successful collisions are more frequent and rate of reaction increases. So if you need to make notes on that, make brief notes on the notes, then you may need to go back and pause the video and make notes on that. Thank you for listening, and I hope you have lots of success in the exam. There is, of course, no luck in exams. You get the mark which you've done the work for. Bye-bye.